wanna do my own thing, but I think I followed a trend. It's been suggested, maybe I wanna be your best friend. Yeah, yeah, blind in my eye holes and just trying hard to see. I can tell by your middle finger that you're warming up to me. Yeah, yeah.
Why, hello. Didn't see you there. Did you know that 1 plus 2 equals 3? Did you know that 1 plus 2 plus 3 equals 6? But then what does 1 plus 2 plus 3 plus 4 equal? Well, that question is for greater minds than ours. Just kidding, it's 10. But then that begs the question, what does 1 plus 2 plus 3 plus 4 plus 5 plus 6 going on towards infinity equal? Of course, what I'm asking is, what is the sum of all natural numbers? Well, our inquiry has to do with infinite series. Okay, so we're trying to figure out 1 plus 2 plus 3 plus 4 and going on towards infinity. What is that equal to? Okay, so in order to figure that out, I'm going to have to pull out some other proofs. So we have 1 plus x squared plus x cubed and so on. And that is equal to 1 over 1 minus x. I'm not going to prove that now, but take my word for it. I have a PhD. This is true for x less than unity. Okay. Okay, so we are going to differentiate this. So we got 1 plus 2x plus 3x squared and so on. When you differentiate 1 over 1 minus x, you get 1 over 1 minus x squared. And thanks to one of the groups for teaching us the quotient rule. So we are going to let x equal -1, and we end up with 1 minus 2 plus 3 minus 4 and so on is equal to 1/4. Now we're going to bring out the Riemann zeta function, which is like something like that. And the argument is s, and that is equal to the infinite sum. One over n to the s. Okay. And this basically ends up being 1 over 1 to the s plus 1 over 2 to the s plus 1 over 3 to the s and so on. So Euler said that s was a real number. What Euler did was that he multiplied the Riemann zeta function by 2 to the negative s. 2 to the negative s. So you end up with that s equals, we end up with 2 to the minus s, I just brought it up from here. Okay. Plus 4 to the minus s plus 6 to the minus s, and so on. Euler did was that he took two of these away from that. So I'm gonna write down the original 1 plus 2 to the minus s plus 3 to the minus s plus 4 to the minus s, so on. And just to make it more visually understandable, I'll line them up. So this is the -2, and then we're gonna put this here, 2 to the minus s, and then plus 4 to the minus s, and that ends up equaling 1 minus 2 to the negative s plus 3 to the negative s minus 4 to the negative s, and so on. So after we got this, Euler then set s equal to -1. S equaling -1, the answer, when s is plugged in, it ended up looking something like this. -3 times 1 plus 2 plus 3 plus 4, and so on. Okay. And just to clarify, this is not -1 plugged into this. This is -1 plugged into the original when we subtracted two of these from that. So this is 1 minus 2 times 2 to the negative s, and then the zeta function. Just move that away from there. Okay. So now that we've used this to get this, we now set that equal to, we now plug in -1 into this orange equation, and you end up with 1 minus 2 plus 3 minus 4, etc. Okay. Now this looks pretty familiar. We might have seen it exactly right here. Okay, and what's that equal to? That is equal to 1/4. Okay, so that equals 1/4. Okay. Okay, and now since we know that this is equal to 1/4, if we divide it by -3, we end up with 1 plus 2 plus 3 plus 4, etc. equals -1/12. So the sum of all natural numbers is equal to -1/12.